finding a rule for a sequence. Once we've done that, we're going to talk about how to get the sequence from the generated rule. Now, this is a sequence 4, 7, 10, 13. I'd like you to pause the video and have a think about what's significant about the sequence. Welcome back. Hopefully you realised it's going up in the same number each time. It's jumping up from 4 to 7, you add 3. 7 to 10, you add 3. 10 to 13, you add 3. But before we talk about the difference, which is going to be clearly something to do with something I've just talked about, let's first of all talk about the term number. The term number tells you what number in the sequence this number is. So this is the first term, therefore term number 1. Next one is term number 2, and so on. So as we discussed before, the first thing to do when calculating the rule or the nth term for a sequence is to calculate the difference. Now the difference is plus 3. So once you've worked out the difference, what you should do is you should work out the 3 times table. So in the final column, I'm going to write down the 3 times table. Pause the video and have a think about what the difference is between the 3 times table and the sequence itself. Hopefully you've had a chance to notice that to get from the 3 times table to get to the sequence, you need to add 1. So it's something to do with the 3 times table, and it's something to do with adding 1 to the 3 times table. Let's bring all these ideas together. The term number means what it goes up in terms of this is the first term, so this is the second term, it goes up in 1s. We've talked about the sequence going up in 3s, the 3 times table, and we need to add 1 to the 3 times table. So our rule clearly is going to be 3n plus 1. This just means 3 times the term number plus 1. Let me show you an example. This we will go into more depth in the second part of the video. 3 times 1, when the term number is 1, plus 1 is going to give us 4, which is this first term here. Then if we were to look at the next one, we would have 3 times 2, so this time we're focusing on the second term, plus 1, and we're using substitution, equals 7. This gives us our second term. So effectively, what this rule or nth term does is calculate what the jumps are between the sequences and how different it is to that specified times table. So this is our rule for the sequence. 3n plus 1 is the sequence 4, 7, 10, 13, 16, 19. For this sequence then, pause the video and have a think about what these go up in. Well done, it's plus 4. So if we write down the 4 times table, we're going to compare the 4 times table to the sequence itself. Now this is different to the previous example. Pause the video and have a think about why. Excellent. Hopefully you notice that what we need to do to get from the times table to the sequence is minus a number. For the previous question on the previous slide, we did something completely different. This is because we had to add a number to get from the times table to the sequence. But this one, as already discussed, we are minusing, but specifically minusing 2. Have a think about what the nth term is. Great. The nth term is 4n. It's the 4 times table, minus 2, because it's actually 2 smaller than the 4 times table. 4 to 2 minus 2, 8 to 6 minus 2, 12 to 10 minus 2. This one is plus 2 again, so we need to write down the 2 times table. And again, we're asking ourselves how we get from 2 times table to the sequence. This time it's like example 2, we have to minus 1. So our rule is going to be 2n minus 1. I'm going to show you a quicker way of doing it without the table, and when you go on to do your worksheet, you can either do it using a vertical table, or you can do it using this method. Another way to do this is to write out the sequence, work out what the difference is in between each term. Clearly this time, as we've already discussed, we are adding 2. You then take this number 2 and you write it in front of the n. That is your first step. In the exam, you would get 1 mark out of 2 for doing that. Final step is to jump back a step here and work out what is the previous term. And this effectively tells you how different this sequence is from the nth term, or how different the sequence is from the 2 times table. So it's -1 different. And this trick just works. You just land on the first number of the sequence and then you continue the sequence, but this time to the left-hand side rather than the right-hand side. And this is a special number. You then just put this next to the nth term, and that is our answer, 2n minus 1. What we're going to go on to next is how to generate the first few terms of a sequence. Stay tuned. Today we're going to learn about what substitution is. We're going to apply substitution and generate the first few terms of a simple sequence, and we are going to find terms of a sequence involving a square and understanding the properties of a sequence. So what we want to think about is, what is substitution? I'd like you to pause the video and have a think about what substitution is. Excellent. Hopefully you remembered from last lesson it involves replacing an unknown letter in algebra with a number. So we can use substitution and sequences in conjunction with each other. For example, if we want to find the first 5 terms of a sequence, we just need to substitute in 1, 2, 3, 4 and 5. So if we wanted to find the first 5 sequences of 2n, we would do 2 times 1, which is 2, 2 times 2, which is 4, 2 times 3, which is 6, 2 times 4, which is 8, 2 times 5, which is 10. So effectively, we get the following. N is equal to 1, 2, 3, 4 and 5, where this represents the number in the sequence. If n is 1, this is the first term. If n is 2, this is the second term, and so on. So for this particular sequence, it's 2n plus 3. So we're going to replace n first of all with 1. So 2 times 1 plus 3 is 5. Then with 2, 2 times 2 plus 3 is 7. Then with 3, 2 times 3 plus 3 is 9. And this is how we generate the first 5 terms of a sequence. This one is slightly different, as this time it's going up in the 5 times table. So we have to do 5 times 1, which is 5, minus 3 is 2. 5 times 2, which is 10, minus 3 is 7. 5 times 3 minus 3 is 12. And you can see there's a connection between obviously the sequence, which involves n, and the sequence itself. This is effectively the 5 times table, but it's starting 3 numbers lower than the 5 times table, which is why it moves from 5 to 2. Have a go at finding the first 5 numbers of each of the sequences and write your answers in the answer box. Hopefully you would have got the following answers. For 3n, this is going to be the 3 times table. So we would have got 3, 6, 9, 12, 15. Now this is a 3 times table, but it's 2 smaller. So instead of starting at 3, we're going to start at 1. So it would be 1, 4, 7, 10, 13. Now,